We're going to look at the inverse question to the normal distribution. And before we start, what we want to do is get your GeoGebra Classic up. So I'm going to go into my web browser, type GeoGebra Classic, and this should come up. And when you first do this, depending on your setting, you'll get this screen. Some of you may get another pop-up that says probability, but in either case, if that disappears or it's not there, you just go to these three lines called the hamburger, go to view, and so what happens is sometimes when you open this up, view is already available. I'm going to select probability calculator and deselect algebra and graphics, and you can also deselect by hitting the little X mark on the screen, but once I do that, I have exactly what I wanted and I'm ready to go. So let's look at this situation. So for the next set of questions, you'll be given the relative frequency, how often, the mean and standard deviation, then asked to find the corresponding measurement. Okay, so this is a little bit different. It's backwards. It's the inverse question. And those, what we're really after is the cutoff between the declared area, or in terms of relative frequency, probability, proportions. Again, the way it's going to be percentile, percentage. Again, the wording could differ, so you got to be understanding that what we're going to be given is the probability, proportion, percentile, percentage, relative frequency, but they all are exactly the same thing. Okay, so let's look at an example just to make this whole thing clear. Imagine a random set of 8 adults. The total weight, sum of weights, is approximately normally distributed. Okay, so as soon as you hear those words, that's something you should lock on. Don't sleepwalk through that. Really pay close attention to what the population distribution is like. All right, but this is what we're looking at is the total weight, the sum of weights, okay, of 8 adults. So that's the distribution we're considering, and it has a mean of 1,400 pounds and a standard deviation of 42 pounds. So I'm going to write this down, and I'm going to write it down using 2 sets of notation. I'm using the variable x. Why? Just because, again, that's just like in algebra, you use x all the time. I'm going to just use x here for just about everything. Unless, of course, we want to get a little more creative. And a standard deviation, so I'm going to write these 2 down because I want to have them available to me. Just away from the question. So it's not too wordy, but I don't want to go back and have to find this. And so these are in pounds. So I'm going to put the units down. And before we get going, I'm going to do one more thing. So we've already got familiar with the z-score formula, which looks like this. And another way of thinking about this is right now, the way this works is that I'm using my variable, my measurement, x, as my input. And then this formula is producing your z-score as an output. Okay. Now, I'm going to solve for x. Right now, the z-score is being solved for. So I'm going to solve for x. So when I do that, I'm going to just do a little bit of algebra, and I show really the average. I'll multiply both sides by sigma. When I do that, I get the following. So I'm going to write it on this side. So I multiply both sides by sigma. I get this equation. Then I'm going to add mu to both sides, and when I do that, I get the following. That. So this now, I've changed the input and output. That's now my input, and now this is my output. And usually when I write this formula down, should make one more mention. So again, in this format, x is my input, z is my output. In this format, the z-score is my input, the measurement is my output. Okay, and now I want to make a mention about this formula, the way it looks, just to get some contrast and comparison going. Remember when we did the fences, you had for example, the upper fence was start from Q3 and then add 1.5 IQR. Okay, so what's the connection between this and this formula? Okay, the Q3 here is a starting point. Mu here is our starting point, is like the 0, okay, the starting point. And then it says add, for the upper fence, 1.5 IQR. But now let's break this down. What is the IQR in reality? Well, the IQR is the middle 50% of your data. But the way we're going to, and the reason we do this is because this acts as variation. So this is a measurement for the variation between the middle 50%, or a type of variation, okay? And then we use this other number to suggest, well, how many of these do we use? In this case, for the upper fence is 1.5. I'm using 1.5 IQR. Well, that's what we're doing here, except instead of fixing it 1.5, we're making this a variable, z. So z serves the same purpose as 1.5. Here, the 1.5 says how many IQRs am I going to use? 1.5 of them to find the upper fence. Here, what it's saying, starting with mu, I need to use, and this is a number we need to figure out, so many standard deviations to get to my measurement. That's the connection between everything. So to do these questions, what you want to do is draw, since we have a normal distribution, draw yourself. This is not an option. You need to do this. And then the only thing I'll remark is the location of the population mean. Great. Now, what is it I'm after? What sum, and these are sums, by the way, because that's what they describe. This is a sum. Okay. Test. So these are sums of 8 adults, and the average of 8, sum of 8 is 1,400 pounds. What sum is a cutoff weight for the top 9%? So the top 9% of weights is, the heaviest. So if we're in the top, it should be above average. These are the heavier. So this is just the average, so it should be above average. So the question is, what is this value? And how often would you get a value equal to that or greater than it? And the answer is 0.9. So notice they're giving you how often you're going to see this number or something greater than it. That's what this is. Like, what is the cutoff? Weight. This is the cutoff right here for the top 9%. So this is my cutoff. Weight. Great. So how do we do this? Well, what we're going to do is find the z-score for this. So right now, you'll notice because the mean is 0 and the standard deviation is 1, these values here are z-scores. When you use any software and you're doing normal distribution, the default is always going to be mu equals 0, standard deviation equals 1. You have to do something to change that. But we're going to leave this alone because later in the class, you're going to meet another distribution where you're not going to be able to change this. We're going to be doing exactly the same process, but you're not able to change it. As a matter of fact, these values show up, but see how these are actually changeable? And that distribution, they're not. So why not just get used to doing this? So we are going to need to go to the top. So I'm going to choose out of my choices here, change my pen color. I need to go to the top, right? And that's why I draw a picture to get myself oriented. So I click on this, and then you should see this thing light up, go on the other side. Notice here in this dynamic version, I need to choose it. Right now, what's chosen, I mean, I can't even see it really on the screen, that's so light, but what's chosen is this in between. I want greater than. When I click on that, it goes to the correct side. Notice it matches my side. So what I want to do now is come here. I'm going to do it on the screen, but I want to just write it down so you have a version of it. You're going to type in 0.9 here. So instead of entering into the input, you're going to enter into the output. So I'm going to come over here and do the same thing. Type in 0.09. Then I'm going to hit enter on my keyboard. And I'm going to do it one more time just to make sure. Sometimes I get confused. And no, it's there. Okay. I wasn't sure for a minute. And this is my input. In other words, what the number I'm after is this, 1.3408. Okay. So now I'm going to use this formula. Now realize that, see that cutoff? See this value, which is in z-score land? This value is 1.3408. So the top 9% of weights as a z-score is 1.3408 standard deviations away from the mean. To get the actual measurement, I'm going to have to use this. So I'm going to enter 1.3408 times, again, my standard deviation is 42.4, plus my mean, which is 1,400. You grab a calculator, and let's see what this number comes out to be. Well, if I'm correct, and you should check me, I'm going to get 1,456.85 pounds. Okay, so what is the cutoff weight? It's this. Oops. Okay, so the top cutoff weight for the top 9% of weights is 1,456.85 pounds, and of course this has been rounded. All right, let's try another one. What is the weight of quartile 1? All right, so if I'm after quartile 1, what I want to do is determine, again, what I'm after. Okay, so again, I'm going to draw my curve here. And you should try to do a nice job on this as best as you can. So there's my curve, but I'm looking for quartile 1. So what is it that I know about quartile 1? Well, quartiles separate the upper 75% from the lower 25%. So that's what a quartile does. So this is Q1, I call this XQ1. So there's my cutoff. Again, this area here being 0.25. All right, so then I'll go to GeoGebra and select the area that I'm after, which is below. So I click on this value. So I'm going to come over here to GeoGebra and select this one. And then what I'm going to enter is 0.25 because I know what this area is. This area is again 0.25. Again, these are z-scores because mu is a 0, standard deviation is a 1. So I'll come over here, type in 0.25, enter, and I get negative 0.6745. Okay, so I'm going to type that in. Negative 0.6745. That's what this produced. So I go back to my formula. So my z-score is negative 0.6745 times how many? The standard deviation, which was 42 point. Let me check above. I'll get this right. 42.4 pounds plus my mean of 1,400 pounds. So again, I'll type that into my calculator. And again, as a reminder, this is what we have is z times sigma plus mu, and the output is x. So I type that all in, and I get 1,371.40 pounds is the quartile 1. All right. So notice the z-score for quartile 1 is never going to change if for a normal distribution. It's always going to be negative 0.6745. Okay. All right. I'm going to not write the interpretation of this just so we save some time. Now we go to this one. What sum is the cutoff weight for the lowest 15% of weights? Again, the lightest. So I'm going to first draw my graph. Again, I'm looking for the lightest. 1,400 here. I was looking for the cutoff, and again, I don't know what this value is, but I'm told that this cutoff separates the lightest 15% of weights. So this area right here is 0.15%, while this area here is 85%. Again, remember, the two must add up to 100%. The question is, what is that value? And again, what I'm going to do is find the z-score associated with this. So come over here, and the question is, what is this z-score? Which again has exactly the same area, 0.15. So I'm going to come over here to GeoGebra, type 0.15, hit return, and I get this value here, negative 1.3. No, I don't get that. One more time. 1.0364. So again, I use this. That's how many standard deviations I'm about to use. So I'm going to use 1.0364 standard deviations. Again, notice the same format, and when I enter all that, what do I get? And I get 1,356.06 pounds, and of course that's been rounded. Okay, let's go through a few more examples, and we'll go quicker this time, since we got the idea here. And you might want to try this on your own and pause me, and then I'll just go through the answers here. Bigger mammals tend to carry their young longer before birth. The length of the horse pregnancies from conception to birth varies according to a distribution that is approximately normal. Okay, so again, important information. We know now that this distribution that we're about to engage in is approximately normal, with a mean mu of 336 days and a standard deviation of 3 days. So I'm going to kind of highlight that. Okay, so mu, or in effect mu of x, or mean of x, again, I'm kind of being lazy with a variable, is 336 days. And my standard deviation, again, this just makes it easier for me to find later. And I'm getting used to both of these sets of notation using the Greek letters or function notation. These are both used all the time, even in the same question. All right, so now I have my information. What day marks the beginning? Okay, the beginning of the longest 8% pregnancy. So, okay, I need to think about this for a second. I'm already getting a little tipsy, but you know something? Here's what I do when I do that. Let me just write down what I know. I know it's a normal distribution, and I mark the location of the mean. That's what I do. Mark this. And now what am I after? What marks the beginning of the longest? Oh, the beginning of the longest. So like I'm marching along. I want to go longest 8% of pregnancy, longest, but the beginning of it is really another word for saying the cutoff. So somewhere here is, I don't know where, the beginning, and then after that we begin the march of the longest 8% of pregnancy. So I'm looking at here. I repeat that little mantra that I just said a couple times until I'm satisfied that I interpreted this correctly. Okay, so now again I come over here, choose my correct symbols. This is what I'm after, greater than. Okay, so again I'm going to draw another curve just to keep this understood in your notes. And when you go into GeoGebra, you're going to enter the z-score, but again, we're after the same area. It's just going to be expressed as a z-score. 0.08. Boom. And I get that 0.08, 8% is 1.4051. Okay. So again, once we do that, we'll use this formula again. That converts from a z-score to my measurement. Okay, where x is my measurement. So I can enter this as 1.4051. My standard deviation is 3 days, and my mean is 336 days. So I enter all that, and hopefully what I'm about to get is 340.21. And again, I popped over here Desmos. When I enter most everything into a calculator, so this Desmos is another online calculator, I'm going to just do it in one shot. So instead of doing it piece by piece, I'm just going to enter all of this at once. So I'm going to get times 3 plus 336. And there is my value. And of course, I rounded this. I should round this to 22 days. I'm going to do that. So that is the cutoff right there. For the longest 8% of pregnancies, again, what value much cuts the cutoff the shortest 3% of pregnancies? So, okay, so now, of course, long and shortest, we have this one we could probably do a lot quicker now because we've sort of getting the hang of this. But now I'm looking for the lowest 3%. So this area right here, what is the cutoff? For the lowest 3%, what is this value? And this area is 0.03. Again, I go to GeoGebra, so I'm going to not do the second graph, but you really should. I'm trying to save a little bit of time. So I'm not saying this is a good practice. I'm just saying I want to just go a little faster. But you shouldn't go faster because you're learning this. As a matter of fact, I'm again so adamant that you must do this, even for myself, because later if I look at my notes, like, well, what did I do? And if I draw these little pictures, it's almost impossible to get confused as to what you did. And if there's a mistake, you'll catch it. There we go. So that's what I found. I get 0.03, 0.08, and now I just enter this into this formula that you see above to figure out what it is. So I'm moving 1.8808 standard deviations, where standard deviation is 3. How many of these am I using? Well, it's in a negative direction, and just under 2 of these I'm using. So it's going to be like 5 something is how many standard deviations I'm moving, but moving from where? From the mean. Notice again, this is coming out negative, so we'll actually be subtracting from this, which is what I want. This value is below the mean. So when I do that, what do I get? Well, again, I'm going to use, again, Desmos, just type it all in. Negative 1.8808 times 3 plus 336, and I get my value, which is 330.36 days. All right, what value represents the 20th percentile? Okay, so this one needs a little more explanation. What is a percentile? The concept of when I see ILE attached to something, what it's trying to say is that this is a form of ranking. And by ranking meaning like the same thing. It's what cutoff. It's really the same thing, but you see this a lot when SAT, like what percentile you get in your SAT scores. It's a way of ranking. What it's saying is there's some value here such that below this value is 20%. Above this value is 80%. So the 20th percentile separates the lower 20% from the upper 80%. That's what a percentile does. Okay, so if it's the 70th percentile, it would separate the lower 70% of all the information from the upper 30%. Okay, and that's what that value is, but that's what we want to know. So again, what I'm going to do is just, and I'm going to skip, I think, finding these values just to speed this up a little bit. Nope, that's not what I want. It's Z. It's doing Z's now. So notice again, I'm drawing my picture. You should do the same, just so you feel comfortable. Okay, and again, the more you do this, the easier it will be for remember. And if you do, another thing to remind yourself, if you do these same steps every single time, then you're going to have the ability to use your muscle memory to go through the process. So notice, even though I wanted to skip this part, my muscle memory doesn't allow me to do that. Like it's already fighting me. Oh, please draw this picture. And this is very helpful because then I'm just sort of going on automatic now that my mind already knows what the process is. I can spend more time thinking about the process than I have to go through it. So even as I'm writing this, for example, I'm just kind of going on automatic mode now. My muscles know exactly what to write. Again, I will enter this into a calculator. And when I do this, I get that the cutoff for the 20th percentile is 338, or the 20th percentile is 338.02 days. Again, it's all been rounded. Okay. One last one. Oh, no. There's one more of that. What represents quartile 3? Okay, quartile 3. So now let's just go back and think about this. Again, let's draw my picture, 336. Ask yourself, what's true about quartile 3? Well, quartile 3 was the separation, right, when we did the box plots. It separated the lower 75% from the upper. So really, quartile 3 is this. What is this value that separates the lower 75% from the upper 25%? Okay, and so that's what we want now as a z-score. Same thing, it's a cutoff here, and it separates the lower 75% from the upper 25%. Now, which one should you do? Should you enter here, choose lower or choose upper? And the answer, it doesn't matter as long as you are aware what these numbers really mean. So if I choose lower, notice I'm choosing lower, I must type in 0.75. When I do that, I get 0.6745. If I decide instead to use this upper part, the 0.25, then I must choose this value, but I must type in 0.25, and when I do that, I get exactly the same number. I rounded that, notice I went 0.6745, but it's the same number, right? Let's just verify. Yep, look at that. So notice it's changing from upper 25% to the lower 75%. The number here is staying exactly the same. The z-score doesn't change because this is a cutoff. So now I'm going to come over here, enter 0.6745. Oh, sorry, positive. Times 3 plus 336, And what do I get? You get, type in 338. Is that right? Oh, this number is incorrect. I was looking at the wrong place. It should have been 333.48 days. Sorry about that. Well, this one, because I have it already written down in some of these questions, just to speed myself up, this should have been 338 days. Again, if I had been paying attention, I should have known that this was wrong. Why? That's a good lesson, but I'm trying to bide my time, because if I'm looking for the 20th percentile, I know I had to be lower than the mean, and when I look at this number, it's actually greater than the mean. So I knew immediately something was definitely wrong, but I wasn't paying attention, which is my fault. Now this is correct, 336. I'm looking for the third quartile, which is above the mean, so that's the least is correct. So lastly, what is the middle 36%? So this one we're just doing so you get used to how to manipulate, or later in the course, this will be important. Okay, the middle 36% just means this. We start from the middle and move out in either direction. No, in both directions, I should say, such that I'm moving at exactly the same distance. So this is equidistant. But when I move, eventually I want to move so I capture the middle 0.36. All right. So now we're going, if that's the middle 36%, you go, oh, wait a minute, there's a little button right here that goes middle. The problem here is that these are moving at different directions, and I just don't have that much control with these little knobs to try and capture 36%. Notice if I come over here, gosh, I'm trying to move them 68%. I'm going to keep moving closer, but it's just a pain to try and capture. Notice I got to get these two numbers to be exactly the same. These are z-scores, and they have to be the same. And I'm trying to get to 36%. So I'll be here all day doing this. So instead, what I do is I'm going to find one of these ends. It doesn't matter which. So 0.36 subtract from 1 will give me the total of two ends. So what is that? Well, that's going to be add 4 here, it gets me 40, so it looks like 0.64. Okay. All right, so now what? Take that number, 0.64, and divide it by 2, and that gives me 0.32, and that's what's at these ends. So this has to be like an equidistant, so the two sides are identical, 0.32, 0.32. All right, so we're going to have to find two numbers here, because I want to find the middle, what days represent the middle 50%. So I need to find really what the question is, what is this value, and what is this value? Okay, capture the middle. The good news is you're going to have to only do the calculation here, or sorry, the finding part once. So if I choose, I'm going to find this z-score first. I enter here 0.32. And then I find that this value as a z-score, so I'm going to make this clear that I'm looking for, I'm finding a z-score, is negative 0.4677. What's on the other side? Well, because I move symmetrically, this value over here should be positive 0.4677. Okay, and again, just to verify, go over here. Notice now, if I just when I click here, I now get the complement, 68%, but I can click over here and then type what I want, which is 0.32, and there it is. Notice it's positive 0.467. All right, so now, again, if I want to find everything, all I need to do is there's two values to find. And I'm going to leave that up to you, but it would look like this. This will give you the upper number of days, and then using the negative will give you the lower. Okay. So again, we're moving. This is all this is telling us how many standard deviations, this is a standard deviation, are we using? We're using, in this case, less than a half. And we're moving in the positive direction to get the upper, and going in the negative direction to get the lower. Okay, and that's really it for finding the inverse.